Good afternoon, everybody. Today in applied physics, we will be studying about rotational motion. Our objectives will be: what is rotational motion? How is it different from translational motion? What is moment of inertia? What is radius of gyration? Then we shall also know what is the physical significance of moment of inertia. There are two basic theorems, one called perpendicular axis, second theorem of parallel axis, and then we will learn some of the applications of these theorems. First of all, let us try to differentiate what we mean by translational and rotational motion. If you see this body AB, then if it moves from one point to the other point, this will be called translational motion. And if the body moves in rotation, then the body will be called to be moving in rotational motion. If you see here, the body is rotating. This is what we mean by rotational motion. If you go in for a bicycle, you see that the wheels of the bicycle, they rotate as well as you do translational motion. So, here both translational as well as rotational motion takes place. Now, when a body rotates about a fixed axis, the motion is known as rotatory motion. A rigid body is said to have pure rotational motion if each and every particle of the body moves in a circle, the center of which lies on a straight line, which we call as the axis of rotation. ਜਦੋਂ ਅਸੀਂ ਰਿਜਿਡ ਬੋਡੀ ਦੀ ਗੱਲ ਕਰਦੇ ਹਾਂ ਤਾਂ ਰਿਜਿਡ ਬੋਡੀ ਮਾਸਸ ਦੀ ਬਣੀ ਹੁੰਦੀ ਹੈ, ਹਰ ਇੱਕ ਪਾਰਟੀਕਲ ਸਰਕਲ ਲਗਾਉਂਦਾ ਹੈ। ਜਦੋਂ ਅਸੀਂ ਪੁਆਇੰਟ ਮਾਸ ਦੀ ਗੱਲ ਕਰਾਂਗੇ ਤਾਂ ਰੋਟੇਸ਼ਨਲ ਮੋਸ਼ਨ ਨੂੰ ਅਸੀਂ ਸਰਕੂਲਰ ਮੋਸ਼ਨ ਕਹਿੰਦੇ ਹਾਂ। ਸੋ ਸਰਕੂਲਰ ਮੋਸ਼ਨ ਯੂ ਕੈਨ ਸੇ ਇਜ਼ ਵਨ ਕਾਈਂਡ ਆਫ rotational motion. Now, it may happen that the axis of rotation lies inside the body or it may lie outside the body. The particles lying on the axis of the rotation always remain stationary. Objects, they can move in many ways. One is translational motion. Translational means straight line motion, in which the objects change their location from one point to the other point and move in a straight line. So, translational motion is one which causes objects to change location. If you see the football here, if it moves straight, then this is what is called translational motion. Now, if the ball rotates like this about a fixed axis, which you call as axis of rotation, then this is called a rotational motion. So, in the case of rotational motion, objects spin in their place. Objects can rotate as well as translate. If you kick this ball, the ball will rotate as well as it will move forward, or else like this top, it can just rotate about its axis. If you see the top view of this top, it will be seen something like this. Then what is axis of rotation? This part along which the body rotates is what is called axis. ਪੰਜਾਬੀ ਚ ਅਸੀਂ ਇਹਨੂੰ ਧੁਰਾ ਵੀ ਕਹਿ ਦਿੰਦੇ ਹਾਂ। So, a spinning top rotates about an axis passing through its center. If you will see from the top view will look like this. So, what is the axis? What we mean by axis is an imaginary line that an object spins around. एक ऐसी लाइन, एक ऐसा imaginary line ਜਿਹਦੇ ਆਲੇ ਦੁਆਲੇ के object spin करता है, उसनों ਅਸੀਂ axis बोलते हैं. Every rotating object has an axis. So, its spinning top rotates about an axis which passes through its center. It is not necessary that the axis at the center of an object. If you take the case of earth revolving around the sun, the axis goes through the sun. So, when earth revolves around the sun, axis is through the sun. When you spin a ruler from one end, the axis is at one end. Now, let us differentiate between rotation and revolution. If you see the earth here, earth is rotating about its axis. When earth goes around the sun, then this is what is called revolution. So, what is rotation? When the axis goes through the moving object. Then what is revolution? When the axis is outside the moving object. Now, let us take up some angular quantities, like in case of translational motion, you say distance, displacement, speed, velocity, acceleration. How do we account for angular quantities in a rotational motion? If you take a purely rotational motion, all points on the object move in circles around the axis of rotation. If you take a point here, if this body, this point is moving around O, then it is moving in a circle. If you take a point nearer, it will also move in a circle. If you take a point further nearer to the center, it will also move in a circle while rotating. But all points on a straight line which is drawn through the axis move through the same angle in the same time. So, if you draw a line here, then all points will be moving through the same angle. So, how will you calculate the angle? You will say it is arc divided by radius. So, here you have taken arc as L, radius is r. So, angle is equal to L upon r. Now, this is what is called angular displacement. So, in the case of rotational motion, linear displacement is replaced by angular displacement. The particle moves through some angle. So, that is the displacement of the particle and we call it as angular displacement. So, here again if you see the particle, if this is the reference line, say it moves through angle theta naught and then it moves through angle theta, difference is theta minus theta naught, which you call as delta theta. This is what is called angular displacement. Now, this is the axis of rotation. This is a compact disc that has been shown. So, angular displacement you can express it in any one of the three units. One is degree. If you go through one full rotation, अगर पूरा चक्कर लगा दिए तो कितने डिग्रीज कवर कर जाओगे? 360 degrees. So, one full turn means 360 degrees. You can also denote it in terms of RPM. RPM stands for revolutions per minute. Or you can go in for the SI unit for this angular displacement, which is called radian. And we had described angular displacement theta as arc divided by radius. If you go through the full circle, then what is the circumference? It is 2 pi r. So, the length that you will cover while moving through the whole circle on the CD will be 2 pi r. If radius is r, then 2 pi r divided by r gives you 2 pi radians. This means 360 degrees is equal to 2 pi radians. Then 1 radian will be equal to what? 360 divided by 2 pi. If you calculate it, it will come out to be 57.3 degrees. So, remember 1 radian is equal to 57.3 degrees. Birds of prey, when a bird tries to catch this mouth, he sees through what angle he has to go so as to catch this mouse. A particular bird's eye can just distinguish objects that subtend an angle no smaller than about 3 into 10 the power minus 4 radian, a very small angle. So, angular displacement, as we had said, is simply the difference of the angle through which the body has moved. Say it moves from this reference line to this point through an angle theta 1 and then it moves through an angle theta 2. So, this difference is what is called angular displacement, theta 2 minus theta 1. Then how do we define angular velocity? You see, in the case of translational motion, you had defined linear velocity as the time rate of change of linear displacement per unit time. When we talk about rotational motion, here we talk about angular velocity. So, average angular velocity is the total angular displacement divided by time. If you see here, the angular displacement is delta theta. Say the time taken to move from this point to this point is delta d, then angular velocity is defined as delta theta divided by delta t. If the time limit is very small, particular instant, say you are asked to find out the angular velocity at a particular instant of time, then that is called instantaneous angular velocity and is represented as delta theta by delta t with the limits of time approaching 0, and we denote it as d theta by dt. Angular velocity is a vector quantity. If you want to know the direction of the angular velocity vector, you curl the fingers of right hand in the direction of rotation. Then the thumb points in the direction of the angular velocity vector. If it is rotating in anti-clockwise direction, your fingers will be curled like this. Then the thumb direction of the thumb will give you the direction of angular velocity vector. If the body is rotating in clockwise direction, then you see the fingers will curl in this way and the thumb goes down. So, it is like this. This is another diagram to show you how you can find out the direction of angular velocity. You wrap the right hand around the axis of rotation, so that the fingers are pointing in the direction of rotation, then the thumb points in the direction of angular velocity. This is what is called a right hand rule for all angular quantities. Angular acceleration is the time rate of change of angular velocity, or the rate at which angular velocity changes with time. If initially say angular velocity is omega 1, after a short interval of time delta t, the angular velocity becomes omega 2, the difference is omega 2 minus omega 1, you denote it by delta omega. This is what is called angular acceleration. If limits of time are very small, then this is called instantaneous acceleration. Now, every point on a rotating body has an angular velocity and a linear velocity. You might have studied this in circular motion. They are related as that linear velocity is equal to radius multiplied by the angular velocity. The objects which are farther away from the axis of rotation, you see this is the axis of rotation at point O, then these objects which are farther away from the axis of rotation, they will move faster, means they will have larger velocity. If the angular velocity of a rotating object changes, then it has tangential acceleration. and if the angular velocity is constant, then tangential acceleration will be 0, but the object will have centripetal acceleration. This means, if a body is moving, is rotating around some fixed axis, then it can have two kinds of acceleration, one called tangential acceleration and the other called centripetal acceleration. So, angular velocity vector points along the axis of rotation with the direction given by the right hand rule. This is what we have studied. If the direction of rotation axis does not change, angular acceleration vector will also point along it. This means, direction of angular acceleration is also along the direction of angular velocity. These are the relations which connect theta, which is your angular displacement. This is the linear displacement, theta is L over r. Now, omega we had said is theta over t. So, theta is equal to omega into t. This is equal to L over r. So, L is equal to r omega into t. So, L is equal to what? V into t, because what is linear velocity? It is linear displacement divided by time. So, linear displacement is equal to linear velocity into time. So, if you put v into t here, t cancels, you get v equal to r omega. Then what is tangential acceleration? It is time rate of change of linear velocity. Now, the relationship between linear velocity and angular velocity is given to be r omega. If you put it here, r radius. So, radius always remains constant, you know. So, radius has been taken out from this differential portion. It becomes r d omega by dt. What is this? We have just learned now. This is angular acceleration. So, tangential acceleration is equal to r into angular acceleration. And what about radial acceleration, which is centripetal acceleration, which you might have studied till now? It is v square upon r, and v is equal to what? R omega. So, r omega square upon r, 1 r cancels, you get omega square r. These are the equations of motion for angular displacements, rotational motion. These are for linear displacements, that is translational motion. You have studied these equations, v equal to v naught plus a t, x equal to v naught t plus half a t square, v square equal to v naught square plus 2 a x, and average velocity is sum of the final and initial velocity divided by 2. Linear velocity is v here, angular velocity is omega square. So, the place for linear velocity in the case of rotational motion has been taken by angular velocity. So, instead of v you get omega, instead of v naught it becomes omega naught. A is linear acceleration, alpha is angular acceleration. So, the equation takes the form as omega equal to omega naught plus alpha t. X is linear displacement. In the case of rotational motion, we take angular displacement. So, the place for x has been taken by angular displacement theta. V naught is initial linear velocity. In the case of rotational motion, it becomes initial angular velocity. A is linear acceleration, it becomes angular acceleration alpha. So, you have x equal to v naught t plus half a t square, or you might have studied as s equal to u t plus half a t square. It becomes theta equal to omega naught t plus half alpha t square. V square equal to v naught square plus 2 a x takes the form in rotational motion as omega square equal to omega naught square plus 2 alpha theta. Now, what is moment of inertia? You have studied about inertia in the case of translational motion. Inertia is what? The resistance that a body provides to change its state of rest or of uniform motion. Moment of inertia is defined with respect to a specific rotational axis. Moment of inertia is defined as the sum of products of masses of the particles constituting the body and squares of their perpendicular distances from the axis of rotation. Say this is the axis of rotation, this is any plane lamina, any body which does not have a fixed shape is called plane lamina. कोई भी body जिसकी कोई fixed shape नहीं है, अगर तो fixed shape है तो ਅਸੀਂ कह सकते हैं कि triangle है या square है या rectangle है या cube है, but if it does not have any fixed shape, we call it as lamina in physics. So, it is what is shown here. This is a body which does not have any fixed shape. It moves around this axis. This is an axis. Axis, I told you, is the imaginary line around which a body rotates. Now, if we consider that this body is constituted of a large number of masses, say m1, m2, m3, mn, as I have shown here, a mass mi at a distance ri. Similarly, there may be mass m1 at a distance r1, m2 at a distance r2 and so on. These are the distances r1, r2, r3, rn etc. of the masses m1, m2, m3, mn etc. from this axis of rotation. Then what is moment of inertia? You multiply square of the distance of the first mass with the first mass, square of the distance of the second mass with the second point mass, square of the distance of the third mass with the third point mass, and you sum of all these. So, it is the product of what? It is the sum of की कितना है जोड़ कितना है किदा products of product किसदा mass multiplied by square of the distance. So, how do we define moment of inertia? Sum of, if you see here, this is sum of what? Sum of masses multiplied by their squares of the position vectors from the axis of rotation. So, this means you can write it as summation miri square I from 1 to n. This is what is called moment of inertia. If you have a point mass is what? Point mass is any body which is whose dimensions are very small as compared to its surroundings. For a point mass, moment of inertia is just mass multiplied by square of the distance from the axis of rotation. If you have a number of masses as are shown here, m1 mass at a distance r1, m2 at a distance r2, m3 at a distance r3, you simply multiply the squares of these distances with their masses and then you sum up. We also call it as sum of the point mass moments of inertia. But if you have a plane lamina like this, then we go in for the integral portion. So, continuous mass distribution, they require an infinite sum of all the point mass moments which make up the whole. How do you do it? You do it by using the mathematical integration over all the masses. Now, on what quantities or what points does moment of inertia depend? As we had seen, moment of inertia is mass into square of the distance from the axis of rotation. So, first of all, it is depending upon the mass of the body. Secondly, it will depend upon distribution of mass about the axis of rotation. Distribution of mass means whether a massive body is near the axis of rotation or a body of lesser mass is near the axis of rotation. Mass कितना distribute होया है? Axis of rotation ਦੇ ਆਲੇ ਦੁਆਲੇ ज़्यादा मास एक्सिस ਦੇ ਨੇੜੇ ਹੈ ਜਾਂ ज़्यादा ਮੈਸਿਵ ਪਾਰਟੀਕਲ एक्सिस ਤੋਂ ਦੂਰ ਹੈ। And third thing, it also depends upon the distance of particles from the axis of rotation, क्योंकि moment of inertia है कि it is equal to m into r square. So it depends upon mass m. R is what? R is the distance from the axis of rotation. And third thing, how the mass is distributed. Now, how mass is allocated, it was called mass distribution of the object. If you see these two objects, they have the same mass, let us say, then which one has a higher moment of inertia? You have a hollow cylinder here, or you can say a ring here, and you have a solid cylinder, that is a disc here. Disc or ring the mass दोनों का same हैगा. This is the axis of rotation, which is shown by the dotted line. Which one has higher moment of inertia? If you give a little thinking, you see the particles in the case of this hoop, they are distributed at a larger distance from the axis of rotation, but here you have got particles near the axis also. So, this ring or this hollow cylinder, the mass is as far away from the axis of rotation as it can be, whereas in this cylinder much of the mass is concentrated close to the axis of rotation. So, moment of inertia of this hoop is more as compared to the moment of inertia of the disc. Now, again let us take these two rods, these are two thin rods. They have the same mass, but let us say you have axis of rotation 1 which is passing through the center, you have axis of rotation which is passing through one end. एक दा सेंटर ਦੇ ਵਿੱਚ एक्सिस है ਜਿਹਦੇ ਆਲੇ ਦੁਆਲੇ ਇਹ ਰॉड ਘੁੰਮ ਰਹੀ ਹੈ, ਇੱਕ ਸਾਈਡ ਦੇ ਉੱਤੇ एक्सिस of rotation ਹੈ ਜਿਹਦੇ ਆਲੇ ਦੁਆਲੇ ਇਹ ਰॉड ਘੁੰਮੇਗੀ. So here what is different? Axis of rotation is different. Now which will have a higher moment of inertia? This one or this one? If you see here, this is the axis of rotation, mass here is much more away, much farther away as compared to this one. So this right one, in this case the mass distribution is featuring at a distance which is much more away as compared to the thin rod, in which case the axis is passing through the center. So this one will have a larger moment of inertia. Now what is the physical significance of this moment of inertia? If we go in for Newton's first law, which we had studied last time, we had studied that a body must continue in its state of rest or of uniform motion unless it is compelled by some external agency which is called a force. अगर कोई बॉडी रेस्ट पोजीशन च है तो वो रेस्ट पोजीशन च ही रहेगी. अगर यूनिफॉर्म मोशन च है, यूनिफॉर्म मोशन मीन्स मूविंग विद अ कांस्टेंट स्पीड, तो कांस्टेंट स्पीड नाल चलती रहेगी जिन्ना चिर उसदे उपर कोई फोर्स ना लगाया जाए. दिस मीन्स कोई भी बॉडी जो रेस्ट स्टेट दे विच है वो अपनी रेस्ट स्टेट चेंज नहीं करना चाहती. अगर कोई बॉडी यूनीफॉर्म मोशन च है तो अपना यूनीफॉर्म मोशन नहीं चेंज करना चाहती. और इसे इनएबिलिटी नूं इनर्शिया कहा गया सी. द इनएबिलिटी ऑफ अ मटीरियल बॉडी टू चेंज इट्स स्टेट ऑफ रेस्ट or of uniform motion by itself is what is called inertia. This is the fundamental property of the matter. And we had studied that larger the mass of the body, higher will be the opposition for motion, means higher will be the inability and larger will be the inertia. So, in the case of translatory motion, mass of the body measures the coefficient of inertia, whereas in the case of rotational motion, moment of inertia measures this resistance. So, in rotational motion also, a body which is free to rotate about a given axis opposes any change desired to be produced in its state. The measure of opposition depends upon the mass of the body and distribution of mass